talk about what the final's going to be on Monday, or when you get your final on Monday, and we will go from there. So that was my plan for the day. You can ask questions about anything. If there's anything you need to go back and review or work on, we can talk about exam format questions, talk about content questions if we need to, talk about this last homework if somebody's still beating on that or whatever, so we can go back and look at anything. So this can be review time, whatever we need to do, whatever we need to cover, okay? Sound cool? So pretty doggone simple, straightforward. So, and if everybody's quiet, maybe we leave early, so. And I'll stay here as long as we need to work on things and review stuff. That's fine with me. So there we go. All right, so the exam, here we go. You will get it on Monday morning, 9 o'clock. So in here, I'll hand you the exam. You guys can start to work on it. And like I mentioned, I will be here to answer questions, to give you some guidance on it and stuff like that. So probably a little more guidance than I would be on a regular hour exam, something like that, on a closed book exam. So I would encourage you to bring your notes with you, and so get to work on it, spend some time working on it, so not just grab it and walk away, but sit down in here, work on the exam, get through as much as you can, make sure at least you know how to do it. If there's some more busy work or something that you need to finish up, but at least you know how to attack it and how to approach it, all that kind of stuff, okay? So what I will try to do, and this is a little bit unusual for me, I typically don't do take-home exams, and so this is going to be a little bit new to me. So the questions will be a little bit different than what you would have had on a regular hour exam, so they might be a little more, and I'm hesitant to use the word involved, but a little more in-depth, so we can do some more things with the questions than you would typically do on an in-class final. And given that it's open note and all that kind of stuff, you know, there's more resources that you can get at and get to. It would not be out of the question to expect a little bit of computer analysis kind of thing, so you may want to utilize like the V-belt. You know, we had some spreadsheets that we put together for V-belts for the Brixius model, some of that kind of stuff, so it would not be out of the question to be expected to do some of that kind of stuff. And so, you know, so we may need to do that either in here or that may be something that you want to finish up afterwards and go from there. All right, so a little bit different format, but content going to be basically the same. So same kind of thing as before, go back through old exams. It will be cumulative, so go back through old exams, go back through homeworks, go back through labs. Those are the kind of things that you'll be expected to be able to do. Okay, so format-wise, it'll be, or content-wise, it'll be very similar to the other ones in that about 30 to 40%, maybe closer to 30% since it's a take-home final, a little bit on the smaller side of that, but it'd be thinking type questions, so short answer, explain yourself, those kind of things, those kind of questions. And then 70% probably in that ballpark of pure analytical, solve the problems, answer the question, come up with a design, whatever. Okay? So that will be the content. The content will be heavier on the last, I didn't put this in here, but on the material that we've covered since the second exam. So it'll be a little bit heavier on that. So maybe closer to half of the exam content, something like that, will be on the last material, and a little bit, you know, around a half, something like that. It'll be a split somewhere in there of cumulative then in the material. What I'll try to do, what I like to do, is kind of integrate some problems so that you'll have some problems that, you know, I got this machine that I have to design, well then I have to figure out how to drive it, so I've got to design a V-belt or chain or something like that to drive it, and then we go on up, or maybe we do fluid power to drive it, and then I got to figure out, okay, what kind of engine do I need to put on the front of it, and all right, if I'm going to buy that engine, how big of an air filter do I need for the air to come into it, you know, so you kind of build all the way back through. But they'll be in pieces, so it won't be like, okay, here's the whole thing, you got to design the whole thing, because that will be, you know, I'll be here till February next year trying to grade those things. But so we'll break it up into pieces, but you know, I like to try to put things together. You can kind of see how everything all kind of fits together. So see what you've accomplished, because you've accomplished a lot this semester. So that's what I'm looking at on it. You'll start at 9. The exam you can submit it on paper if you really are ambitious and get her done. Submit it on paper, or Monday or Tuesday next week. If you want to just write it down on paper and be done with it, slip it under my door if I'm not in my office, or knock on the door if I'm there and hand it to me. So you can turn it in that way. Anytime on Monday or Tuesday. If you're going to submit it electronically, it is due by the end of your final exam period, which is Friday. I looked it up, so near as I can tell, it's Friday from 8 to 10 is when we should have been taking the final exam. So it'll be due by the end of the time on Friday. All right. If you turn it in electronically, please make my life somewhat sane. So don't take a whole bunch of pictures and then just attach them to an email that I've got to figure out, okay, which is page 1, which is page 2, and print them out. Put them together in a PDF. So there's scanning software, you guys have it on your phones, you can use your camera or whatever, but make sure that they're all successive pages in a single PDF. So what you email to me is a PDF attached to an email, and I can just hit print on it, and it comes out on the printer and stapled together, and it looks just like the exam. So that's what I want to be able to do, okay? Does that make sense, what I need to do? So yeah, no JPEGs embedded in an email or something like that. So I want to be able to print it out. I have to print them out to keep, it's part of our, we have to keep records of stuff. That's part of university rules and so forth, that we have to have final exams for so many years. So I got a whole pile of them that I forget to throw out. So. But yeah, I have exam final exams. So that's what I got to do. Okay, make sense on that? All right. Any questions on format? That kind of stuff. Take notes on a computer. I know Carson does, maybe some other people taking notes on computers. You can have your computer with you, so if you want to bring your laptop on Monday, that would be fine. So if you've got notes on there, or you want to work on some of those spreadsheet programs and stuff like that, so that would be okay as well. All right? So, open up. Okay, so, things barking and doing weird stuff. All right. So that's flashing and blinking. I got a light up here flashing and blinking. I'm going to have a seizure for a minute here. If I do, just ignore me. I've never had one. Good. All right, so what did we cover? Let's see. So the last exam, as I recall, we covered fluid power. So what was not on the last exam was starting on the right-hand side on mechanical power transmission. Is that correct? I believe that's where we cut this off. Is that what you guys remember?
The mechanical power was on the list.
Oh, yeah. No, you're right. It was. Okay, so it's basically from human factors on, and then there's a little bit on the other side, on the back page. Yeah, what we got to do. So, yeah, you're right. So, human factors is, we'll look at, I'll kind of step through those real quickly. So, a lot of discussion on this, and discussion of standards. So, there could be some standards involved that you may need to either look up from our class resources, or if I've got copies of them or whatever. So, that there may be some standards work that we got to look into some standards. In fact, there probably will be that you'll have to dive into some standards somewhere. But understanding a little bit about safety, environmental factors, the operator space controls. So not a lot of analytical stuff there, but a lot of discussion points and everything, and why we don't make the gear shift purple, and those kind of things in the cap. So that's what we're looking at there on human factors stuff. We had a chapter, and I realized as I was putting this together, we never really did a homework on that, on the chapters on planting and chemical application. I don't think, did we? We didn't have a homework assignment on that. So there will be a little less material from that in terms of problem solving, but there's some pretty basic stuff in there, and again, because this is a take-home exam, you can probably figure some things out. So there could be some basic kind of things in there in terms of field efficiency, coverages, stuff like that. We did a little bit of that on the labs, looking at overlaps and coverage and all that kind of stuff. But I think capacities are important, so being able to calculate a field capacity, being able to use some efficiencies in terms of what field efficiency means and stuff like that. And I went over all those things in those videos. So it's some pretty basic analytical stuff that we can figure out, either from the chapter or just common sense. So a lot of that is just pretty basic common sense kind of things on there. So that's what the kind of things that would pull out of those two chapters in terms of application. Again, the key thing would be field coverage, field efficiency, field capacity, those kind of things. How much can I cover? How much can I get done in a certain amount of time? And that kind of thing. Okay? Makes sense there? So that's that. The next chapter then was the biomass harvesting. And we talked about moisture and storage in there, different biomass concepts, and so that's always interesting. It's always interesting working with people that don't understand that stuff. So, and I'll stop and tell you a story. When some of the first hemp work that we did, we had a company came to us and said they wanted us to build that hemp harvester that some of you saw is down in the courtyard, it's down in the lab there right now. But we're clipping the tops off the hemp so that they could get CBD out of it. They're going to do the processing and stuff to get the CBDs. And so we built this harvester, and I kept asking them, I said, what are you going to do with the plant material? We're going to cut it. Do you have a way to transport it and all that kind of stuff? Because we're just putting them in these big pallet sacks, the 3 foot by 3 foot by 4 foot or whatever sacks. We were just packing it in that. And said, it's a green plant material. You stick it in a pallet sack, it kind of gets warm and does, oh no, we know what we're doing, we got a processing facility and everything, we can handle that and all that kind of stuff. It's like, okay, so first time we dumped it in the pallet sack and we sent it, with them, and they called me up the next day, it's like, that stuff all got hot and started to rot the next day. It's like, yeah, I told you it was going to do that. It's green plant material, that's what happens with it. So the next time we did a field experiment for them, they said, oh, we got to figure it out, we're bringing a refrigerator truck. It's like, you really don't understand plant materials. So unless you freeze it completely, just cooling it down isn't going to stop it from getting hot. Them bugs are going to work in there. And so they had a reefer truck full of plant material that all got hot and started to rot on them too. So it was kind of fun, but understanding that, hey, it's a biological material. It's got bugs in it. It's going to do things, and so that's kind of what makes us unique in a lot of ways as biosystems engineers. We can build machines where we're also interacting with that green plant material, with that living organism, and so how do I interact with that, and how do I understand enough about it that I keep my life sane. So that was an interesting story. I had to stop and tell you that. So at any rate, storage and moisture contents and some of that stuff we talked about in there. Cutting, the knife descriptions, we talked a little bit about sharp, dull, and blunt, and fine, and all that kind of stuff, and again, that's any kind of knife. That's not just for biomass, go in the medical field, how sharp's your scalpel? What do you mean by sharp? What kind of knife am I talking about? Everything there, so it's the same kind of terminology that you got to look at. We did some homeworks on that, of course, with the chopping and length of cut and those kind of things. So that's what you got back there. So there was some, a few people stumbled on a couple of those problems, so make sure you look over those solutions and understand how to do those problems. So the solutions are up there. On that, so the chopping, length of cut, so those would be certainly things that I could expect you to be able to do on the exam. And then the densification, we talked a little bit about baling and densifying and stuff like that. So that was that there. And then the last chapter was conveying, so forces involved and flowability of grain or granular materials or whatever kind of materials that we're conveying. So we could have soybeans and corn is kind of easy. It flows like a granular material. But what happens when I start to get into biomass material? How does it flow? How does it move? So it's kind of some interesting challenges that engineers have to face there. And then the different types of conveyors. So we did some homeworks on a screw conveyor, on a pneumatic conveyor, on bucket and paddle conveyors. They're very similar, but basically just a bucket that. How much is in the bucket? How many buckets go past? The really interesting thing with the bucket conveyors is they come up the top and then they go around. So there's a speed limitation because I need to make sure that that grain exits off of the top of that thing. That's what we're talking about in the video. So if it goes too fast, I bring the grain right back down the bucket, that doesn't work. If I go too slow, it just kind of falls down the bucket. So there's a given speed that'll launch that grain and make sure that it exits that bucket in the right way and come out of that conveyor. So some interesting things that go on there. So those bucket conveyors and the paddle conveyors there at the end, the belt and paddle conveyors. So belt conveyors are pretty simple, you know, it's just put a paddle on it, how big is the paddle, how fast is it moving, so that's how much goes on. Some interesting things there. So, but I'll show you pictures and videos, I forget, of the really long conveyors. So, you know, like several miles they're running these big, it's just mind-boggling. Look at these huge belt conveyors that are moving mining material and stuff like that across the land, so it's crazy. There's some big ones out in western Kentucky, anybody travels out there, so some of the strip mines and stuff that are moving coal into some of the loading facilities along the river, so taking coal out of the mines and putting it into barges, so there's some pretty long, big conveyor systems out there. So that was that. Forage blowers are just weird things because they're not really blowers, they're throwers. But there's a combination of throwing and momentum, and now we get pneumatic type forces going because we get the air moving and all that kind of stuff, so it's a real complicated deal. Analytically, so that's what we are looking at there. So we didn't do any problems on that, but just understanding those concepts of what that and how that's working. 3 different regimes on those forage blowers and that kind of stuff. All right? So that's kind of the last stuff, and then the first stuff, you know, is the same as what it was. Just copied off of those initial review sheets that we had for the first 2 exams. So again, there will be some cumulative stuff. I would go back through the exams, former exams, and there were a couple problems that gave quite a few people some problems. So those are things that, you know, I want to see that you've cleaned them up. So kind of go back and make sure you can do all those. The solutions for those exams are up on the web, on Canvas, under the files. All the homework solutions are up under files. All except for this last one. Then I will get it up hopefully sometime tomorrow, Thursday at the latest, or Friday at the latest. But I'll try my best to get it up sometime tomorrow morning so that you've got that to study for over the weekend to look at. And give you as much of a head start as possible on the exam on Monday. So, again, hope you get through as much as you can. And, you know, maybe even finish it up. I think it might be possible to finish the thing up on Monday if you would like to do that. And you're comfortable doing that. That's what we got, okay? I rambled and I rattled. What questions do you have on anything? Does it make sense?
Will we be able to email you after Monday if we come up with something that we didn't get to ask, like afterwards?
Yeah, if there's some questions about you don't understand what I'm looking for in the problem or something like that, yep. So I'll monitor email and try to watch that. So, you know, when my in-laws and everything, and I've got cousins or nephews and stuff coming over Thanksgiving, so it's going to be kind of bedlam. So it may not be on it, you know, every 10 minutes, but I'll try to respond over the holidays and early next week if you need to have some questions on that stuff. Yep, if you don't understand the questions. So absolutely. Same as you would in class here.
You do number 3 off the homework?
Can I do the one that you turned in today?
Yes.
That you're working on right now? That Cynthia's still working on? Help me out. All right, so let's set it up. Which one was number 3?
Power, pneumatic conveyor.
Oh, so the whole pneumatic conveyor?
Yeah.
So I have not done that solution, so I'm not going to be able to step through that problem specifically.
Okay, well, what was like ballpark of the answer supposed to be?
You know, I don't even know. I didn't even run it. No, it's going to be an unreasonable power. So if you got a really high power, you're probably right, because that's the nature of pneumatic conveying. All right, when you're trying to convey this stuff and you get a truckload of power, that's what they do. So that's a huge sacrifice that you're going to pay for a pneumatic conveyor. So it's going to take a lot of power, and you're going to have pretty limited capacity. So we're pushing the capacity, trying to make it the same as what you would see with a screw conveyor and a belt conveyor, that paddle conveyor or something like that. And that's going to take a lot of power to make that happen, because you're moving air and going around corners, especially the miter corners probably killed you on that. So So those really made the pressures high. So yeah, if you got a really high pressure, really high power, yeah, no surprise.
Okay.
No surprise there. So it probably does end up coming out there. All right. So were there questions on some of the individual parts there that?
No, I was just like, this is wrong.
This is wrong because I got a really big power. I could not have done this right. But yeah, you probably did. And that's part of that reason for that exercise is, you know, we're trying to do the same exact thing with 3 different types of conveyors, and that's one of the things that we realize from it is like, yeah, no, you know, they're different conveyors for different reasons to accomplish different things. And so, you know, the screw conveyors, the belt conveyors are different, but they handle things, you know, handle a little bit more capacity. So the pneumatic conveyor, I use it when I have to get up and over and around and through and do something a long way. That's when I use the good pneumatic conveyor. So yeah, so if that is assurance is enough, you know, I can go and look at some specific things and how to set it
Well,
up.
I'm sure it's still wrong. Is it?
There's little
How
things,
wrong is it?
little things here and there that are wrong on it. So yeah, I'll put the solutions up, and then you can wade through those solutions, obviously. But you know, it's going to be, if you follow the same kind of thing. You know, the example that we did in class, we ended up with a lot of horsepower, or a lot of power. It wasn't kilowatts, but we ended up with a lot of power, so, and it's going to be unreasonable. Katie's laughing, you really got a lot of power, huh?
Yeah.
So, and then, you know, and the difference is, probably what really kicked you over when you laid out all those pressures, I'm guessing that bends, the pressure for the bends was probably the biggest one.
No, the biggest one was just the flow of the grain.
Just the flow of the grain,
It was
yeah, just a
ridiculous.
lot of grain. So, but yeah, going around the bends would have been big too, but yeah, that's a lot of grain to push through there, so the pneumatic conveyor, you'd have to really back that capacity
It
off
was
to
like
make it.
2 cubic meters per minute going through a 2-inch diameter pipe.
Six, yeah,
It's
six
just
inches.
ridiculous.
Yeah, no, it is, it's a ridiculous solution, it wouldn't work, so there you go, that's what you learn, and that's what you go to people and say, yeah, you don't want to do this. You're gonna need a big old lot of horsepower to make this happen, so that's not unusual, that's not out of the question that you see something really weird like that, so, yep. No, I expected that, I just, you know, I made those numbers up and I didn't run a solution, but I fully expected that the power would be, you know, ridiculous and be astronomical, so, yeah, don't do that, try something different, go back to the screw conveyor or something like that. Right. So what's the problem with the screw conveyor? We didn't talk a lot about screw conveyors, but, so we use them a lot, but there are some issues with them.
They don't turn.
What's that?
They're only straight.
They're only straight, yeah, they can't go around the corner. But think about handling grain. An example that we used to use, we used to do some things with like freshmen and stuff with popcorn. So if I run popcorn through a screw conveyor.
Clogged.
What's that?
Would it clog?
Clog? Let's say that I, you know, designed it right so it doesn't clog, it goes through. But what's that screw conveyor going to do to my popcorn?
Damage it.
What's that damaging? Does that matter?
Absolutely, if you want to keep it.
That's right. If you want to pop it, you know, how does popcorn pop? And that's one of the big examples. And it's a kind of a cool thing that we used to do with freshmen is just give them a pile of popcorn kernels and a little piece of sandpaper. And all you do is take that kernel and just scratch the edge of it. Just go right along the sandpaper like that. You know, every kernel, you sit there and do that. And you put it in an air popper. And of course, the way it pops is it builds up the moisture inside the kernel, builds up pressure. And it's literally an explosion. So what you see is a frozen explosion of that starch that comes out, you know, that solidifies like that. So you see that frozen explosion. Well, if that shell is damaged just a little bit, it doesn't build up as much pressure, so you get the little, you know, half thing opens up and a little bit of stuff sticking out, but you don't get the really big fluffy kernels. And it is really, you know, you can really tell that in the damage and everything. But again, that example where just, you know, every kernel, just take one little scratch on the side of it. That's all you have to do with sandpaper, just one little scratch, and you put them in a cup and then pop them. And, you know, you get about this much popcorn as opposed to that much. So handling and you know, what you're doing to that material, how much you're beating it up, how much you're scratching it, and all that kind of stuff is a really big deal, you know, thinking about grain quality, especially if the grain, you know, if it's going to get ground and processed, who cares if it's going for seed to grow again, you know, the viability of the seed, or, you know, like a popcorn or something like that. It's a big deal what we do to the grain. So thinking about that kind of damage in the different conveying conveying type devices. And what they're doing to my product is a real big deal. So, anyway, a little extra there for you, something like that. But popcorn things are fun for kids. All right, other questions? Go back to content or anything?
How many questions will take?
I have no idea. I really don't. I have to give another final tomorrow, so that in my other class, that's my top priority right now is working through that final with them. So I probably won't work on this final till Friday. Would be my guess.
Will it be longer than a normal one that we would have like just in class then?
It would, not an awful lot longer, so no, I don't expect it to be, you know, excruciating long. So this is not something that's gonna take you 8 hours to do at home, so it's gonna be, depending on what mood I'm in and where I go with it and how much I ask you to do with some of the spreadsheet tools and stuff like that, it may be possible to actually finish it on Monday. It may not be out of the question to do that, so I'll kind of design it within that 2-hour time frame kind of mindset that it would not be completely out of the question to be able to finish it there, you know, if you really wanted to just drop it and walk away. So, maybe a little bit that you've got to do with some, you know, with some computer, do a spreadsheet or something, a little bit more in-depth analysis, since it is, you do have the opportunity to take it home, so we'll build a little bit more depth into it, but yeah, this is not something that you can expect to take 6 or 8 hours to do. You know, we could do that, but I'm not going to. So this is going to be, you know, something that'll be closer to what you can finish in an hour and a half, 2 hours, you know, in a normal final exam period. Okay. So good question.
If there's a spreadsheet problem, how are we supposed to show like the work we did?
I'll figure that out. Print it out maybe, or something like that, you know, so, or just give you the numbers, copy the numbers down, so, yep. So I'll figure that out, but I'm just saying it's not out of the realm of possibility yet, but yeah, that was one of the questions that I was thinking about too, I'm sure how we go about doing that. So, all right. Anything else? Other questions? I will be available the next couple of days, and of course nobody travels anywhere anymore, so I'll be available if I'm not in the office to meet with me. We can jump on Zoom together if you've got some questions or something like that. So, you know, like I said, on Monday I'll give you a little bit more direction maybe than I typically would with a regular hour exam, but it's not, I'm not going to sit there and show you how to solve the problem either. So, you know, you've got to do some preparation on your own, some work on your own. So if you do have some questions, you know, that really don't understand how to do this thing, so we need to have those conversations before Monday. But anyway, we'll kind of play that by ear a little bit on Monday. All righty. I'm good if you guys are. Any questions? If you got individual questions, I will
Thanks, man.
stay in chat. Oh, by the way, double check the grade. I've updated the grades this morning with everything that I have. So double check, make sure that everything matches what, you know, what I turned back, and I didn't make any mistakes on what I recorded. So this got assignments coming in all over the place. They kind of do get lost a little bit more this semester than they ever had before. So just double check, make sure everything is right on that. Carson, I just found one of yours that I have that got buried. So there's one score that's not up there now that I'll get up for you.
Oh, yeah. Yeah, we did. I might have. You want to? You got 100.
Oh, I was just wondering, it was just like, I don't know what it's all about him.
Yeah, I think we got back.
Take your word for it, man.
Yeah, I don't know where I put it. It's somewhere out there.
Somebody's got it.
Yeah.
Okay. That's fine. Maybe I'll have this other one done for you when you swing by.
Have a weekend.
You too, enjoy yourself. We're finished. We're done.
It does look reasonable. It does look stupid. I stared at this for a good 5 minutes, and it doesn't feel right. Our velocity of my air is 73 meters a second, and I'm like,
Well, you did better than I did, so mine was higher than
Well,
that.
it's a fairly small pipe,
yeah.
and it's a lot of material, so yeah, so it might be. So what, yeah, the problems we did in class were on 30 to 40 meters per second, so 70 would not be unreasonable. That's a lot, which
Almost
is,
everything I'm getting is like double what we had.
yeah, well, it's a small pipe
Yeah.
that you're trying to push through,
Yeah.
and it ain't gonna work. That's what you're gonna find out.
Like, I've heard that, and it makes me feel good about it. But also, Reynolds number of 740,000
Yeah, no, that's
is a lot.
That's a big Reynolds number, that's right. No, and it's, you know, sometimes you have to run those numbers and put it on paper and show somebody, hey, don't do this, this is a dumb idea.
Hey, don't. Or do, I mean.
Or, hey, if you want to do this, man, I'd love to
I love
put in an 800 horsepower electric motor to